since the space environment is not exactly the best for plant growth, then it's important for us to understand how they respond in microgravity. Now, this latest experiment is called Seedling Growth, and it uses the model plant Arabidopsis thaliana, or commonly known, and I like to say, Thalcress. It studies the effects of various gravity levels on the growth responses of these plant seedlings. Images of the seedlings are then captured and downlinked to Earth. Plant samples are harvested and preserved on orbit for analysis on Earth. Now, the results of this experiment can lead to information that will aid researchers in food production studies concerning future long-duration space missions, as well as data that could improve agricultural production and higher crop yields on Earth. And the Payload Operations Integration Center here in Huntsville is vital to the success of this experiment. And joining me now is Carol Jacobs. She is a Payload Operations Director in the Payload Operations Center. And Carol, you've been working with the crew members and developers all around the world on this Seedling Growth experiment. First of all, tell us how the POIC is involved in this.
Yes, Lori. The Seedling Growth experiment takes place in a facility called the European Modular Cultivation System, EMCS, as we like to call it.
That's right.
And the team on the ground works both with the science team in terms of controlling the conditions inside the EMCS and with the crew when they're working with us, taking the seeds in and out. And the first thing the crew does is insert some little seedling cartridges inside the EMCS, and we work with the crew during this process in case they have any questions with the procedure or they're uncertain about what's going on. And the real-time critical aspect of this experiment is when the seeds have germinated to the right size and it's time to take the little cartridges out and freeze them. And I think we're probably going to see some footage of this, but the crew members take the seedlings, the little cartridges out of the EMCS. They have to get them ready to freeze inside Melfi. Melfi is one of the freezers we have on the space station, and that will stop all of the chemical and biological processes inside those seeds and freeze them until we can return them to the ground and get them back to the science team. So we work with both the crew and the ground team working towards a successful mission.
Tell us a little bit more about the EMCS facility. It has a lot of capabilities, right?
Yes, it does. Growing plants in space, of course, is a little bit different on ground. You don't have sun you've got 8 to 12 hours, and you also don't have any gravity. So inside the EMCS, we've got some rotors, and by rotating those at different speeds, we can control the gravity environment. Roots, of course, like to grow down. On space station, there's no down, so we start with a 1 gravity environment, and once we get germination, then we can change to 0 G if that's what the experiment wants. We can also control the lights. We have blue lights and red lights inside EMCS, and the plants respond differently. Both the roots and the seedling part of the plant respond differently to those lights, and the scientists can decide what they'd like to provide.
Very interesting. We can see the crew working on it right now. You were actually on console when a crew member was working with this experiment and actually looked into the centrifuge, the EMCS, and said, something's not right here.
That's right, Lori. That's one of those calls you really don't like to get, is when the crew calls down and says, you know, there's some little particles floating around inside here. And our first concern, of course, is the safety of the crew member. We want to make sure they aren't exposed to anything hazardous. And we pretty quickly determined that that wasn't anything hazardous. It wasn't mold. It wasn't any sort of dirt, because these little seeds actually grow in a growth medium. But we're also concerned that the science itself is not compromised and that the facility is healthy as well. Working with the science team, the EMCS team, the team in Houston, we pretty quickly determined that the crew was safe, the hardware was fine, except we did have to do some R&R on the space station. Turns out the belts were degrading that helped control the rotors, or the centrifuge. So crew on the ground provided a new procedure for the crew. We sent that up. The crew was able to replace those belts just fine, and since then we've actually grown some new seedlings. So we're back in a nominal configuration, and that's sort of the perfect example of a troubleshooting plan by everybody from the ground to the crew.
That's great. It's kind of like your tractor breaking with
Absolutely.
space, but
absolutely.
Does it feel like to you that sometimes you're growing a garden in space helping with this?
You know, it does. It's not quite like the garden I have in Huntsville with my big pea pods and my big tomatoes. These are pretty small little plants, but they're sure paving the way for future growth of real plants that the crew can harvest and enjoy on space.
I know a lot of interest in this one, and let's take a look now in the Payload Operations Integration Center, a live look where Carol works. and real busy this week, right, Carol?
Yeah, we have 2 new crew members. They're still getting used to living on space station, and since they're sort of new up there, we're really interested in how their bodies are responding to the space environment. So this is a week with lots of human research experiments from ultrasounds of their eyes, ocular health, to collections of biological samples, urine, blood, saliva.
All the fun stuff.
All the fun stuff, yeah. So they're human guinea pigs this week. And we also have always lots of science going on that the crew doesn't help with. Some of the experiments we're working on this week are scan test bed, STPH3, and SIR. But probably have to wait to talk about those another day.
All right, we will do that. But if you'd like more information about these experiments and more, you can log on to nasa.gov/station.